Let's analyze our data for the dilutions or spec solution lab. So the first thing we did was we made a 0.1 molar concentrated solution of copper sulfate, and then we diluted it. We took half of that out of the container, we put 50 mils of water with it, we cut it in half, and so that's why the concentration went down by a half. And then we did the same thing. We cut that in half with water, and we made a 0.025 molar solution. Then we measured the absorbance of all of these, and then we also measured the absorbance of some unknowns. And so now what we're going to do is take these three numbers, these first, that if we know the concentration and the absorbance, we can make what's called a calibration curve. And this is very similar to what you did in the pre-lab. So we're going to make our calibration curve, and then we're going to use the slope and the intercept from that line, the best fitting line, to help us figure out what the concentration would be for these two unknowns. So I'm going to open up Excel here, and I'm going to type in my concentration and absorbance data. Now, make sure you don't have any units on the concentration. You just want to put numbers in Excel. So if there's a molar in this table, just get rid of it. I'm going to retype everything. I've got 0.1, I've got 0.05, 0.025, and then your absorbances might be different. That's perfectly fine. I'm guessing over here what these would be. And then I've got my unknown 1. I'm not going to put the unknowns in the graph because I don't know what the concentration is. That's the whole point of making the graph. I don't know what these two are. I'm going to find them. Okay, so after I have those typed in, I am going to highlight these two rows, and I'm going to go up to Insert, find this little scatter plot, click on the one with all the dots, boom. And then I want to check and make sure that it plotted the right things on the right axes. I want to have the absorbance over here, and I want the concentration down there. So let's make sure that it says, 0.1. Great, so this is my absorbance, right? So those should be, the first one should be like 0.45, sure. And then the next one should be, yep, 1.22 on that side. Good. So it looks like this is right. My absorbance is right. If you're getting on the bottom axis here, like 1, 2, 3, and it's just plotting those points. It's not reading this data. It's just saying that this is 0.1, this is 0.2, this is 0.3. Make sure that you don't have any concentrated units in here, like an M or any other weird things. It should just be the numbers. All right, so once I have that, I can just click on this little, what is that, a cross, and click on axis title so I can label these so I don't get confused. I know down here, I want it to say concentration. Concentration, and then over here it's absorbance. This is my calibration curve. Great. Great. And now if I want to make the trend line, I'm going to click on that dot. I can right click until it says add a trend line. That's fine. I can scroll down here and say display equation on the chart. That's my equation. You can also do that in here and then just click on trend line and then carry that over. It's a linear graph and the same options should come up. Great. So that's my equation. And now I can use that equation. This is y equals mx plus b, where y is the absorbance and x is the concentration. And so I have y values. These are my y values here, and I'm going to solve for the x. I'm just going to plug in that for y, and then I'm going to solve the x, which is the concentration. So I'm going to go back over to my Word document to do that. So the equation of the line I got was y equals 30.086x minus 0.295. Great. You will probably have a different value. That's a different equation. That's great. That's for your data. The slope is right here. It's that 30.086. The intercept is the 0.29. So you should get something pretty close to 0 there. I'm going to use the intercept and the slope and everything to solve for my unknown now. Okay, so I'm going to take all of this. This is the equation I'm looking at. I'm just going to copy that down right there. And for y, the first one, I'm going to do this twice for each one of my unknowns. I'm going to put this y in here. Great. And now I'm going to solve for x. So I'm going to add, right? Since this is a minus over there, I'm going to add my 0.295 on both sides, add 0.295 on both sides. Great, so on the left, I end up with like 1.945 is equal to 30.086x, and I'll divide both sides by the 30.086 divided by 30.086, and that gives me an x that is equal to 0.065 molar. So that's what I got for my unknown concentration 1. Here I got 0.065 molar. I'm going to do the same thing for the second one. I have the same equation. I just have a different absorbance. Put that down here. And instead of that absorbance, I'm going to use this one, 0.86. So I got 0.86. And so I'm going to add my 0.295. End up with 0.8895 equals 30.086x. Now divide by 30.086. 30.086. So I end up with x is equal to, I got 0.0295, which I'm just going to round to 0.030 molar for my second one. Here we go, 0.030 molar. A couple things to note. So because my intercept here was a negative, that's why I added on both sides. If yours was a positive, then you would subtract on both sides. And now let's just check it. Let's just check our work to see if that even makes any sense when we look at our graph. So for this one, we got a concentration of 0.065, and this one we got a concentration of 0.030. Does that make sense? Okay, so how do I check to see if that makes sense? So for this first one, 0.065. So if I go over here on the bottom to find the concentration, so 0.7 would be about there. So 0.65 would be about here on my concentration. If I draw a line over the absorbance, it should have been somewhere between 1.5 and 2, and it was 1.65. So that makes sense. Let's check this one. 0.03. I'm going to find 0.03 on my graph to be right here. Draw a line up, and the absorbance should be between 0.5 and 1, and it was 0.86, so it was between 0.5 and 0.1. So my answers kind of make sense here. These are my final answers, so those are the unknowns that I was solving for. So in your abstract and your conclusions, you want to say that. You say, oh, we found unknown concentration, the unknown solution had a concentration of 0.065, and then the second one had a concentration of 0.030, or whatever you get your answers to be.